First of all, let's define what is meteorology. Meteorology is the branch of science that studies the atmosphere and all the physical processes occurring within it. Now, the term atmosphere refers to a gaseous layer that surrounds a planet, in this particular case, the Earth. The Earth's atmosphere is divided into different layers, each one of them with different pressure, humidity, density, and temperature characteristics. But we will look at this layers more in detail in a future video. Let's go back to the general concept of meteorology. This term comes from meteor, which is defined as a non-permanent natural phenomenon that occurs in the atmosphere, and it may consist of either a precipitation, a suspension, or a deposit of liquid or solid particles, or in some cases, it may also be a form of optical or electrical phenomena. Now, at this point we must clarify that the term meteor is not the same as meteorite or meteoroid, since these are different concepts that refer to a solid object that comes from space and penetrates the Earth's atmosphere. With this being said, according to their nature, meteors can be subdivided into different classes. There are, for example, hydrometeors, which are water-related phenomena in a liquid or solid state, such as clouds, rain, or fog. There are also lithometeors, which are related to phenomena formed by particles other than water, such as smoke, dust, or sand. Then we have photometeors, which are related to optical effects in the atmosphere, such as a rainbow. And finally, we have electrometeors, which are related to electrical phenomena, such as lightning or aurora borealis. So, now that we know what meteors are and how they are classified, let's take a look at two important concepts. The first one is weather. Weather is defined as the set of atmospheric conditions present at a given time and place, which are constantly changing, and they are practically unrepeatable. Weather is measured by parameters such as current temperature, pressure, wind direction and speed, humidity, visibility, and any present atmospheric phenomena. With this in mind, a regular weather report would be like, today at 2 p.m., Brisbane is reporting a temperature of 19 degrees Celsius, a relative humidity of 64%, sky partially covered with clouds, etc. Now, the other important term is climate, which is defined as the average weather in a certain place or region in the longer term. Climate is mainly conditioned by the geographical characteristics of the area, such as the latitude, type of surface, elevation above sea level, among other factors. For example, we can say that the city of Manaus in Brazil has a rainy tropical climate, because those are the most common weather conditions that we can find there. And on the other hand, we can say that the city of Cairo in Egypt has a dry desert climate. Now, this does not mean that every day of the year will be like that. It only implies that those are the most common conditions in that region. So as we can see, weather refers to the specific atmospheric conditions at a given time and place, while climate refers to the typical or average atmospheric conditions of that place in the long term. Now, one of the factors that significantly determines the climate in a certain region is its latitude. As we can see in this map, the Earth has different climate zones that depend mainly on how far or how close they are to the equator. In this case, the areas closest to the equator are warm and humid, while the areas closest to the poles are much colder and drier. So, having already understood the concepts of weather and climate, let's look at another two terms that are commonly confused, which are meteorology and climatology. Let's start with meteorology. This branch focuses on the observation, study, and short-term forecasting of atmospheric conditions. It allows to determine with fairly good precision the behavior of the atmosphere at a specific moment in time in the near future. On the other hand, climatology focuses on the study and long-term evolution of the climate in order to elaborate concrete models of the behavior of the atmosphere. It helps to develop more solid long-term forecasts and anticipate climate changes in a certain region. Now, after looking at all these concepts, you might be wondering, what do the weather conditions actually depend on? Well, weather conditions are the result of the interaction of the Earth's surface and the atmosphere. However, that interaction is affected by several factors. More specifically, the main factors that determine climate on a large scale are the amount of solar radiation absorbed by the surface and the Earth's rotation. In fact, we can say that the sun behaves as a kind of weather engine for the planet, since thanks to these two factors, the Earth's surface is heated unevenly, which generates pressure differences between different areas, which in the end trigger all the weather phenomena that we know. In addition to this, we have to mention that the Earth's axis of rotation is tilted in relation to the ecliptic or orbital plane around the Sun, which greatly affects the distribution of solar radiation on the planet along the year and generates periodic climatic changes in the northern and southern hemispheres, known as the seasons of winter, spring, summer, and autumn. However, we have to mention that other factors, such as the type of surface, terrain characteristics, and relative humidity, also condition the climate on a local scale. Now, it is evident that atmospheric conditions have a significant impact on human life. That's why, since ancient times, climate and weather have been studied with the aim of predicting certain conditions or phenomena relevant to some human activities, such as agriculture. Its importance has been so great that the study of climate dates back to 340 BC, with the publication of Meteorologica by Aristotle, where there was already speculation about the factors influencing the atmospheric conditions. Later, with the advance of technology, different instruments and techniques began to be used to evaluate and predict the weather. Specifically, one of the first instruments used for this purpose was the barometer, which basically is an atmospheric pressure gauge. The first barometers related atmospheric pressure directly to the weather conditions that could be expected, as we can see in this image. This way, if there was a high pressure, then a good dry weather could be expected. But if there was a low pressure, then a bad, stormy weather could be expected. However, this was not the only instrument used to measure weather variables. Other relevant instruments used were the thermometer, weather vane, anemometer, and the hygrometer. Now, thanks to advances in technology, nowadays there is a complete and modern infrastructure of sensors and instruments that allows observing and forecasting weather conditions with much better accuracy. Within this infrastructure, we can highlight surface weather stations distributed throughout the planet, weather balloons used to measure temperature, pressure, wind, and humidity at different altitudes, and even satellites that send weather imagery on different channels. Now, it is important to mention that not all meteorological reports and forecasts are the same, since meteorology is subdivided into different branches depending on its practical application. For example, there is maritime meteorology that focuses mainly on the phenomena and variables that affect the navigation of vessels. There is also agricultural meteorology that focuses on the atmospheric conditions that affect crops. And obviously, we also have aeronautical meteorology, which focuses specifically on the phenomena and conditions that can affect air operations. With this in mind, it is really important for a pilot to understand how different atmospheric phenomena behave and how they affect an aircraft in flight. This way, failure to identify or to properly react to certain hazardous weather conditions may lead to catastrophic consequences. Therefore, the main objectives of the study of aeronautical meteorology are to understand the physical processes and meteors that occur in the atmosphere, know and identify dangerous weather phenomena for aviation and how to reduce the risks related to them, know how to read and understand the different types of weather reports and forecasts required for the planning and execution of flight, and correctly analyze and evaluate the present weather conditions in order to take the most appropriate decision and course of action given the circumstances.